Thanks for tuning in. We're continuing onward with our journey of salary elevation and technical growth. Today, we're going to be working on the LRU cache problem. This is a medium problem on LeetCode. It's number 146. So let's get started. Here's the problem description. You can take your time to read it. Basically, we're going to be implementing an LRU cache, least recently used. It's comprised of three methods: the constructor, which will initialize it, a get, and a put. Um, the put is interesting because if we have exceeded the number of capacity, then we evict the least recently used key. And the get and put must each run in O of 1 average time complexity. We'll go down here to the constraints, take a look at them. We'll zen in. All right, so with this type of problem, I'm assuming the interviewer will most likely expect you to program like a doubly linked list in order to handle this with a hash map. So they want you to code the nodes. I've been doing this for a while, so we're going to skip that step and just hope that you can understand the logic. But this problem here pretty much says that we need a hash map in order to handle the cache, and we need a linked list or queue in order to handle the at least recently used keys. So let's get started. Create a hash map of integers for the cache. Create a linked list for the queue. I'll create a global capacity integer. All right. Now we'll get started with initializing them. All right, so the constructor's done. Now, what we want to really get done here is in the get, we want to return the value of the key if it exists, otherwise return -1. So the reason I'm using a hash map here is because a hash map has O of 1 complexity and retrieval, and it's pretty much a key value pair here, so it's perfect. But it can't keep track of the most recently accessed or least recently accessed unless we were to use a linked hash map. This could be used. I feel like that's a little bit cheating for the problem, but just make note of this class. It's pretty useful for a lot of things. We'll skip to the basics and go here. So for get, we want to return the value of the key if the key exists, otherwise return -1. So let's get started. Cache, if the cache doesn't, we're going to return -1. Otherwise, it does exist. So we want to, if it exists, we need to get it, which will also cause it to be accessed and used. So that means it would bump it up in the most recently used list. So first off, we're going to need to remove the key if it exists already in the queue. It could be hidden back there. So we're going to remove it. And now the remove for the queue, this method has two different pretty much usages. You can remove an index or you can remove an object. We are going to remove the object. So that means we need to cast the key as an object. Otherwise, it will just try to remove that index. You could get an out of bounds error. It could get a little tricky. So we remove that. Then we add in the exact same key because we just accessed it. And then we're going to return the key. Okay. And that should be sufficient. And now for the put, this is kind of where most of the meat is because we need to compare the capacity. So first off, update the value of the key if the key exists. Okay. So we're going to go here. If the cache contains the key that exists, so then we'll put it in there. And then we're going to remove it from the queue again, like we just did earlier. Well, via casting it. Then we offer it back up. And then here, the cache is full. Remove the least recently used. And a linked list is FIFO. First in, first out. So the least recently used will always be first. Now this could be done more efficiently with a doubly linked list because you could be putting in the most recently used in the back, and you could be popping off the top from the least recently used, and that would be more efficient. But we'll just go with the linked list for here. So if it's full, if the cache size if it's at the current capacity, we're going to remove the least recently used. And then we will merely add it in. And that should work, hopefully. All right. So we successfully solved the LRU cache problem here. We did so using HashMap and a linked list. Now, if I was going to do this again to make it more efficient, there's a few ways you could go about it. You could, we'll share screen here. Instead of using a linked list, utilize a double linked list and add the most recently used element to the tail of the double linked list. This would keep this would allow for the least recently used to be held at the head of this list, so we could pop off immediately and not have to traverse the list. Or we could program our own double linked list utilizing node classes and accessor methods. Or we could use the linked HashMap, which is a perfectly fine data structure to be used in this problem. I guarantee the interviews probably won't like the fact that you're ignoring half of the work they're wanting you to program. So this solution, if you can see down here, whoops, wrong hand. That it's O of 1 per time and O of capacity for space. So I hope this was helpful, and keep on keeping on. This journey takes a while. Only the strong survive. Until next time.